8.4 Nuclear Physics. Previously, we have learned about the Bohr's atomic model. Bohr said that an atom consists of an electron that moves in a circular orbit of radius r around a positively charged nucleus. And we already focused on electron, the movement of electron around the nucleus. Starting from this subtopic, we are going to focus on the nucleus. A nucleus consists of neutron and proton, and you can get the nuclear number by using this equation. A equal to Z plus N, where A is the nuclear number equal to proton number plus neutron number. For example, 8.8, determine the number of protons, electrons, and neutrons for each of the following nuclei, assuming the atoms are neutral. First one, for helium. Proton number is 2, neutron number is 2, while electron number is 2. For sodium, proton number is 11, neutron number is 12, while electron number is 11. For uranium, proton number is 92, neutron number is 143, while electron number is 92. Isotopes, they are atoms whose nuclei have the same proton number but different nuclear number. So the examples are given here. We have isotopes of carbon, hydrogen, and also oxygen. The principle of energy mass equivalence is important when you want to convert from the unit of mass into unit of energy. So they are related by the equation of E equal to mc squared. This is Einstein equation. So here you can see that if you want to convert energy from the unit of electron volt to joule, mega electron volt to joule, or you can also convert the mass given in U, unified mass unit, into kilogram joule. You can also convert U into electron volt or mega electron volt. The symbol C right here is referring to the speed of light, 3 times 10 to the power of 8 meter per second. Example 8.9, calculate the energy that is equivalent to 2.5 gram of an element in the unit of joule, electron volt, and also mega electron volt. So from the given mass 2.5 gram, we want to convert it into energy in the unit of joule, electron volt, and mega electron volt. So how do we get energy from the given mass? We can use Einstein equation E equal to mc squared. Substitute the mass, substitute the speed of light, then you will get the energy. Okay, let's see the answer. When you want to substitute the mass into the Einstein equation, make sure that the unit is in SI unit. So mass, the SI unit is kilogram. So you need to convert 2.5 gram to kilogram, then times it with the speed of light squared. You will get your answer in SI unit, which is in joule. To convert the unit of joule into electron volt, then we can divide with 1.6 times 10 to the power of negative 19. From that equation, you will get 1.41 times 10 to the power of 33 electron volt. Now, to convert into mega electron volt, kita nak tambah 1 prefix. Then, divide it with 1 times 10 to the power of 6. Then, you will get 1.41 times 10 to the power of 27 mega electron volt. Mass defect and binding energy. When a proton and neutron, they combine or bound together to form a nucleus, there will be mass defect. The total mass of a nucleus always less than the sum of the masses of its nucleon. So when we combine these two, it will form a nucleus. Nucleus will have less mass compared to the summation of mass of proton plus with the mass of neutron. So the loss of mass is also known as the mass defect. You can calculate by using this equation, delta M equal to the proton number times with the mass of proton plus with the neutron number times with the mass of neutron minus with the mass of nucleus. When we have this mass defect or delta M, it is then converted to energy released when the nucleus is formed from its individual nucleons. In order to separate the nucleons, energy is required. So when we have a proton and neutron, they bond together to form a nucleus, the energy will release. But if we want to separate the nucleons into individual proton and neutron, energy is required. So how to find the energy? We will use this equation, E equal to delta M C square. So this delta M, you can use this equation and then substitute the speed of light. You will get the energy released when we want to bond together proton and neutron, or the energy required when we want to separate proton and neutron from a nucleus. This is the example for the mass defect. For example, we have a mass of proton 3 kg, mass of neutron 2 kg. The mass of nucleus should be 5 kg. Okay, because it is the combination of proton and neutron. But we will get mass less than 5 kg due to the mass defect. Binding energy is the energy required to separate the nucleons into its separated neutrons and protons. This is what I have explained just now. You can use this equation, E equal to delta M C square. Example 8.10, calculate the binding energy in joule and mega electron volt for a helium atom given that the mass of helium nucleus is 4.0015 U and mass of proton and neutron are given here. First, we can find the mass defect by using this equation. The number of proton for helium is 2 times with the mass of proton. The number of neutron for helium is also 2 times with the mass of neutron minus with the mass of nucleus. You will get 0.0305 U. Convert it into kilogram and then substitute into the equation of E equal to delta MC square. You'll get the answer in joule. If you want to convert it into mega electron volt, you can divide the answer in joule with 1.6 times 10 to the power of negative 19. Then you will get 2.85 times 10 to the power of 7 electron volt. And then if you want to add prefix mega into this value, divide it with 1 times 10 to the power of 6. You will get 28.5 mega electron volts.